Hello students, so this is of Vedanta Axel class 10 optional mathematics. So we are in the coordinate geometry, resuming the part, the pair of straight lines. In the previous I did up to 12b and the video got interrupted, so I'll be continuing from 12d. Okay, so yes, let's dive into number 12d. So we have to find the angles. Okay, so finding the angles, so we have to build the equations. We have x squared minus 2xy cot 2 alpha minus y squared. Okay, that is equals to 0. Now comparing with x squared plus 2xy plus by squared is equals to 0. We get a is equals to 1, x is equals to, you'll get negative cot 2 alpha, and b is equals to negative 1. So from here you can clearly see, you see a and b, when you sum up, the resultant will become 0. So you can directly write since a plus b is equals to 1 plus minus 1, which is 1 minus 1 equals to 0. Since a plus b is equals to 0, therefore theta will be 90. Okay, so a plus b is equals to 0, it is the condition of perpendicularity, so it's finished. Okay, or you can apply the formula tan theta is equals to plus minus 2 root h square minus ab divided by a plus b. Okay, so this one is the shortest route that I have provided. You can see the conditions. If you can apply the conditions a plus b equals 0, then it will be 90 degrees perpendicular to each other. Okay, without further delay, let's move on to number 13. So now in 13 number, you have to separate equations. You have to find two separate equations represented by that single equations. Okay, so we have already done that, but what to do if there is given this trigonometric functions instead of some numerical value constant. So in case of that, what to do is, I'll just show you here. Okay, in this case, so given equation, try to factorize this. Okay, now 2xy cot alpha, here nothing means there is always 1. Okay, now x squared plus 2xy cot alpha, now 1 can be written as cosec square alpha minus cot square alpha, and there is already y squared there, is equals to 0. Or x squared 2xy cot alpha negative, now multiply this minus cosec square alpha y squared, and minus minus plus cot square alpha y squared is equals to 0. Now, or x squared plus 2xy cot alpha, just bring this here, plus cot square alpha y squared, and move this to the backward, is equals to 0. Now we can see here, so this part, the a part will be x and the b part will be cot alpha y. Okay, a square plus 2ab plus b square. It can be written as x plus cot alpha y whole square minus, now this can be written as cosec alpha y whole square is equals to 0. Now here a square minus b square, it can be written as x plus cot alpha y plus cosec alpha y, and that is x cos alpha y, and another is x plus cot alpha y minus cosec alpha y is equals to 0. So from here you can write either x plus cot alpha y plus cosec alpha y is equals to 0, or x plus cot alpha y minus cosec alpha y is equals to 0. So this I and this double I, these are the two separate equations of this line. Okay, similarly, just like here, in this case also you can do in the same way. Okay, from here x square minus 2xy sec alpha. So instead of sec alpha you can write here, nothing here means 1. Okay, sec alpha, sec square alpha minus tan square alpha, you can write here equals to 0. So sec is connected with tan, that's why x square minus 2xy sec alpha plus sec square alpha y square minus tan square alpha y square is equals to 0. Now we can see here this part can be written as x minus sec alpha y whole square. This whole part can be written as this. Now minus tan alpha y whole square is equals to 0. Okay. After this, this a square minus b square. Now this can be written as x minus sec alpha y plus tan alpha y x minus sec alpha y minus tan alpha y is equals to 0. Either x minus sec alpha y plus tan alpha y is equals to 0, or x minus sec alpha y minus tan alpha y is equals to 0. So these are the two separate equation of straight lines represented by this single equations. Okay, this is how it is done. So 13a and b I have done. So what the remaining left is c and d. So without any hesitations, I would like to rub this and continue that another part. Okay, so okay, so I'm going to start c and d. If you have finished this, then okay. If you haven't, just take a screenshot, and I'm going to rub this. Okay, now let's go into number 3c. Just like in the previous, we are going to just do in the same way. This cosec is connected with cot. Okay, so we'll be applying that formula. Okay, now here you just see x squared plus 2xy. In case of cosec, nothing here remains 1. So cosec square alpha minus cosec is connected with cot square alpha, and there is y square already is equals to 0, or x square plus 2xy cosec alpha plus cosec square alpha y square minus cot square alpha y square. Now it's just, this whole part can be written as x plus cosec alpha y whole square minus cot alpha y whole square is equals to 0, or x plus cosec alpha y plus cot alpha y. Another is x plus cosec alpha y minus cot alpha y is equals to 0. Either x plus cosec alpha y plus cot alpha y is equals to 0, or x plus cosec alpha y minus cot alpha y is equals to 0. So these are the two straight lines which is separated from this equation, single equation. So similarly, just like that, this also is this x squared minus 2 times xy cot 2 alpha. So minus, this can be written as cot is connected with this cosec square alpha. So here is 2 alpha, okay? So you have to write the angle 2 alpha because here is 2 alpha. So cosec square 2 alpha minus cot square 2 alpha y square is equals to 0, or x square minus 2xy cot 2 alpha minus cosec square 2 alpha y square plus cot square 2 alpha y square is equals to 0. Okay, now just bring this here. X square minus 2xy cot 2 alpha plus cot square 2 alpha y square cosec square 2 alpha y square is equals to 0, or x minus cot 2 alpha y whole square minus cosec 2 alpha y whole square. Now this can be written, this whole can be written as a minus b whole square, and this, okay. Now a square minus b square, you can just cot 2 alpha y plus cosec 2 alpha dot y. A plus b and another minus a minus b. So a plus b, a, oh my god. So here you just forget to write minus, so x minus cot 2 alpha y, a plus b, a minus b. So either cosec 2 alpha y is equals to 0. This is I, and another, or x minus 2 alpha y minus 2 alpha y is equals to. So these are the two separate equations. Okay, this is how it is done. Okay, this is nothing, this is just like the previous one. It's just very simple. These are the trivials one. You have to do this, okay, with the same manners, nothing more new here. Okay, so with saying that, Now I would like to start that the long questions, some of the questions, the long questions that yes, 14, 15, 16, 17 and 18. I would like to start that. So I need to rub this, clear this board out. Okay, everyone. So if you finish, then okay. If you haven't, just take a screenshot, and I'm going to start that number 14 onwards. Okay, so I'm going to rub this. So this 14a, this is of long questions. Okay, you have to find the equation of two lines represented by that given equation, 2x squared plus 7xy plus 3y squared. Okay, so you have to separate that equations, so that single equations that will gives two separate straight lines. So you have to separate that, and after that you have to find the angles between them. Okay, find the point of intersection also. So in this case, so 14a, given equation, a given single equation, we have 2x squared plus 7xy plus 3y squared is equal to 0. So here you just factorize this. 3 to the 6, 6 times 1, 6, 6 plus 1. So I'm going to do here directly. 6xy plus xy plus 3y squared is equal to 0. So here 2x will be common, 2, 3. Here y will be common, x plus 3y is equal to 0. So x plus 3y, another 2x plus y is equal to 0. Either x plus 3y is equal to 0, or 2x plus y is equal to 0. Okay, so these are the two separate equations of straight lines. Okay, so they don't have the constant terms. Okay, since I and double I, since I and double I, they both passes through the origin, therefore their point of intersection will be 0, 0. Okay, so in this both equation, okay, in this both straight lines, they don't have the constant terms. So if the constant terms is absent, in that case both the lines, they passes through the origin. Okay, which means this also passes through the origin and this also passes through the origin, which means they have the common points. The point of intersection will be origin, so their point of intersection will be origin O, 0, 0. Now we have to find the angles between them. So if you want to find the angles between them, just compare. So let's comparing single equation with x squared plus 2xy plus by squared is equal to 0. We get a is equals to 2, b is equals to 3, and h is equals to 7 by 2. Then apply the formula. Tan theta is equals to plus minus 2 times h square minus ab divided by a plus b, or tan theta is equals to plus minus 2. So h we have 7 by 2, whole square minus a we have 2, b we have 3, divided by 2 plus 3, or tan theta is equals to plus minus 2. So that will be let's say 49 by 4 minus 2 3 is 6 divided by 5, or tan theta is equals to plus minus 2. This 5 will go to the denominator while reciprocal. Inside that 49 minus 24, 4 6 are 24, or tan theta is equals to plus minus 2 by 5 multiply 49 minus 24, that will be 25. From 25 5 will be out, and from 4 2 will be out, which is tan theta is equals to 5 5 cancel, 2 2 cancel, the remaining inside the will be 1. Theta is equals to tan inverse plus minus 1, which is, if you take positive sign, you will get theta is equals to 45 degree, and take negative sign, you will get theta is equals to 180 minus 45 degree, that is 135. Therefore the value of angle theta will be 45 and 135 degree. So this is how it is done. Okay. So after this, let's move on to the number 14C. So I'm going to rub it. Okay. So if you have finished, then it's okay. If you haven't, just take a screenshot and you just copy that later. Okay, I'm going to rub it now. Okay, now let's move on to the 14C. Okay, in 14C, yes, in 14C you can see here, just factorize this. You have to find the single equations, and since it passes through the origin, because it doesn't contain the constant terms here, so it will obviously passes to the origins when these lines are separated. So those lines will be passing to the origins. It means the point of intersection will be 0 0. And comparing these equations with x square plus 2xy plus by square, you can find the angles between. Okay, so here, just like we did in the earlier, I just factorize this. Okay, 2xy cos sec alpha. Now nothing here means 1, so instead of 1 you can write here cos sec square alpha minus cot square alpha. So this equivalents to 1. Alright. Cos sec alpha plus cos square alpha y square minus cot square alpha y square is equal to 0. Got it? Okay, so now this whole terms can be written as x minus cos sec alpha y whole square minus this can be written as cos alpha y whole square is equal to 0. Now either no, not either this is A and this is B. A plus B and another is equals to 0. So A plus B, A minus B. Now we can do either x minus cos sec alpha y plus cot alpha y is equal to 0. This is I. And another x minus cos sec alpha y minus cot alpha y is equals to 0. This is double I. Okay, so these are the two equations from this single equations, separated from these single equations. Now after this, since they both since I and double I, they both passes through the origin. So therefore their point of intersection will be same. Intersection will be origin 0 0. Okay, now you have to find the angles. Now comparing this single equations with, I'm going to draw a boundary line. This is the boundary line. Okay, separating. Okay, comparing this single equation with ax squared plus 2xy plus by squared is equals to 0, you will get the value of a 1, b also 1, and at you will get minus cos alpha. No, not cos alpha, cosec alpha. Then we know tan theta equals to plus minus 2 times h square minus ab divided by a plus b, or tan theta is equals to plus minus 2 h we have minus cosec alpha whole square minus a we have 1 and b also 1 divided by 1 plus 1, or tan theta is equals to plus minus 2. So here cosec square alpha minus 1 divided by 2, or this 2 to get cancelled here. Tan theta is equals to plus minus, now this can be written as under root cosec square alpha minus 1, which is, yes, cot square alpha, or tan theta is equals to plus minus cot alpha, obviously. Now here tan theta is equals to plus minus, cot can be written as tan 90 minus alpha, or theta is equals to plus minus 90 minus alpha. Okay, therefore theta, if you take positive sign, this will be 90 minus alpha. If you take negative sign, this will be alpha minus 90. Got it? Okay, this is how it is done. So this is the angles. Okay, so I have done number 14, A and C. Number B is up to you. You have to do that. Okay, if I do all, then you will be paralyzed. Okay, now let's move on to number 15. Okay, so I'm going to rub this. If you want to copy this, just take a screenshot. Now I'm going to rub this. Okay, now let's move on to number 15a. Find the pair of lines parallel to x squared minus 3xy plus 2y squared is equals to 0 and passing through the origin. So which means this one. So first I would like to cover this one questions. So 15a. Let's move on to the 15a. So given equations. Given single equations, we have x squared minus 3xy plus 2y squared equals to 0. So you have to, find the equation, find the pair of lines parallel to these equations and passing through the origin. Okay. So you have to find a pair of parallel lines. For that, first you have to, just separate this first. You know how to separate. You just factorize that part. Okay. Just factorize that part. Okay. Now just factorize 2 times 1. 2 plus 1 3. I'm going to do here directly 2xy minus xy plus 2y squared is equals to 0, or x common, x minus 2y minus y, x minus 2y is equals to 0, or x minus 2y and another x minus y is equals to 0. So two lines, either x minus 2y is equals to 0, this is I, and another x minus y is equals to 0, this is double I. Now you have to find two other lines which are parallel to this and this. Now the equation of lines, parallel to I and double I and passing through the origin is given by so in case of parallels, this two part will be same. So since it passes through the origin, so since it passes through the origin, it doesn't have the constant, just like this, the line that we have to consider which passes through the origin also will be the same. So the equation of line parallel to this I is given by x minus 2y. Since this part passes through the origin, it doesn't have that constant term, so x minus 2y equals to 0. IV, this is 3, let's 2, let's consider this 3, and the equation of line parallel to this line will be x minus y is equals to 0. So here triple I and IV are the required two equations. Got it? Okay. So after this, let's move on to the 15b. Okay. So without further delay, I would like to wrap this 15a. So I'm going to start 15b. Okay. So let's move on to the 15b. With doing 15b, you will be more clear about the situations here. Okay. So in the 15a, you have to find the equation of parallel lines which are parallel to the given equations and it passes through the origin. So in that case, there will be no constant terms. But here, instead of passing through the origin, the parallel lines which are parallel to those lines will be passing through this point 1 2, which means that it will contains the constant terms. So here the first part will be the same. Okay, just factorize this. 2 5s are 10 and 5 plus 2, that will be 7. So I'm going to do here directly 5xy minus 2xy plus 5y squared is equals to 0. Here x will be common, 2x minus 5y. Here minus y, 2x minus 5y is equals to 0. Or 2x minus 5y, x minus y is equals to 0. Now either 2x minus 5y is equals to 0, this is one line, and or x minus y is equals to 0, that is another one. Now you have to suppose now equation of line parallel to line I and double I is given by given by 2x minus 5y plus k is equals to 0. Let's consider this triple line, and the line parallel to this line will be 2x minus 5y. In case of parallel, these terms will be unchanged, and plus k since it passes through the 1 2. If it passes through the origin, this k constant terms will be nothing. There will be nothing, but instead of there is given, since it passes through the point 1 2, that's why I have given here k. Later you have to find the value of k. Okay, so the equation of line parallel to this line is this, given by this, and the parallel to x minus y equals to 0 is given by x minus y plus k equals to 0. Let's consider this IV. Okay, respectively. Now, since line triple I passes through which point? 1, 2. Then just replace the value of x by 1 and 2 by 2, y by 2. So 2x minus 5y plus k is equals to 0. Now 2 times x we have 1, y we have 2, plus k is equals to 0. So 2 minus 5 to the 10 plus k is equals to 0. And then negative 8 plus k is equals to 0, or k is equals to 8. Therefore, line triple I becomes what? 2x minus 5y, and you have k is equals to 8. Replace the value of k by 8 is equals to 0. Okay, and also line IV passes through point 1 2. Line IV also passes through the point 1 2. Then just replace the value x minus y plus k is equals to 0, or 1 minus 2 plus k is equals to 0, or minus 1 plus k is equals to 0, or k is equals to 1. Therefore, line IV becomes x minus y plus 1 is equals to 0. Therefore, require equation of lines parallel to the given line and passing through the point 1 2 is this. One is this and another is this. Is 2x minus 5y plus 8 is equals to 0, and another x minus y plus 1 is equals to 0. So very easy questions they are. Just you have to know the basics how to do it. Okay, so first you have to suppose the equation of line parallel to the whichever equations. Then so if that equation passes through certain points, you have to satisfy that point into that. Okay, just replacing the value of x and y with the respective components, you will get the value of k, the constant terms, and by later you just replace the value of k and you will get the exact equation that you are looking for. Okay, so with saying that, I would like to start 15 finished. I would like to start number 16. Okay, so I'm going to rub it. So if you have finished, then that's okay. If you haven't, just take a screenshot and later copy that. Okay, I'm going to rub it, scrub it. Okay, number 16a. So in the 15 number, you have to suppose the you have to find the equation which are parallel. Now in this case, you have to find the equation which are perpendicular. So you know how to suppose the equations, the perpendicular equations given to the respective straight lines. Okay, let's move on to number 16a first. So a number, we have the given equations, given single equations. Given single equations, you have x squared minus 5xy plus 4y squared. So the first step, you just factorize this. X squared minus 4xy minus xy plus 4y squared is equals to 0, or just x minus 4y minus y will become in here x minus 4y is equals to 0, or x minus 4y x minus y is equals to 0. Now you just write either x minus 4y is equals to 0, I, or x minus y is equals to 0, double I. So now you have to find the two other equations which are perpendicular to this line I and perpendicular to this line double I. Now equation of line passing through the origin. Passing through the origin means it will not contain the constant terms. Okay, so now the equation of line passing through the origin and perpendicular to line I and double I is given by now you can see here. So for the line to suppose perpendicular to this line I is just reverse this, change the sign of this middle. Okay, change the sign of this middle and reverse the coefficient. Okay, the coefficient of y, for example, this is x and y. Now the equation of line perpendicular double I is the equation of line. How to suppose the equation of line perpendicular to I? Okay, this I, we have x minus 4y is equals to 0. So in this case, when you try to when you suppose the equation of line perpendicular to this line I, you just exchange the coefficient of x and y. So here the coefficient of y is 4. Now the 4 will be coefficient of x here. Okay, the coefficient of x is 1 here. Now the 1 will be the coefficient of y. Now since this sign there is negative, now you just write here positive. So this will be line perpendicular to line I. Suppose this is triple I. And so in the same way, just reverse the coefficient x, y. So both have the coefficient 1, it doesn't matter. So this negative will becomes positive. Okay. Now, so these are the two required equations. Let's just write respectively. Okay. These are the required equations of lines. Yes. Very easy. Okay, now without further delay, I would like to start number 16b. Okay, if you don't mind. Okay, so I'm going to rub this. Okay. Let's move on to number 16b. So we have the given equations here. Now in this case, it does not passes through the origin. Now it passes through the 2 3. So in that case, it will have the constant terms. You have to suppose that by k in additional. Okay, now we just factorize this first. Try to find separate equations at first, separate lines, two equations of a straight line. So here 2 4 is 8, 4 plus 2, that will be 6. X squared minus 4xy minus 2xy plus 8 y squared is equal to 0. Or x minus 4y. So take this 2y and x minus 2 plus 8 is equal to 0. Or x minus 4y and then x minus 2y is equal to 0. Either x minus 4y is equals to 0 or another line x minus 2y is equals to 0 double I, right? Okay, all right. Then now the equation of line, perpendicular to I and double I is given by, so here 4x plus y plus k is equals to 0 and 2x plus y plus k is equals to 0. Okay, so I have accessed the coefficient of x and y and change the middle sign. Okay, since just I forgot to write here respectively, since line triple I passes through which 2 comma 3, then just 4x, replace the x by 2 and y by 3 and you will get the value of k. 4 times 2 plus 3 plus k is equals to 0. 4 to the 8, 8 plus 3 plus k is equals to 0, or k is equals to 8 plus 3, that will be 11 minus 11. Therefore equation 3 becomes 4x plus y. Just replace the value of k by minus 11 equals to 0. Again, since line IV also passes through the point 2 comma 3, then we can write 2x plus y plus k. Just get the value of k here also. Replace the value of x by 2 and y by 3 plus k is equals to 0. 4 plus 3 plus k is equals to 0. 4 plus 3 negative 7. Therefore equation IV becomes 2x plus y minus 7 equals to 0. Therefore the two required equation of lines are, one is 4x plus y minus 11 equals to 0 and another is 2x plus y minus 7 equals to 0. Done. It's that simple. Okay, so after this, if you have finished, then okay. If you haven't, just take a screenshot. Okay, after this, let's move on to the number 17. Okay, okay, so if you don't mind, I'm going to rub this and I'm going to start number 17. Okay, okay, so I'm going to rub this. Okay, all right, it stands. I'm going to rub this. Just take a screenshot if you haven't. So now in 17a, so I'm only going to do 17a. Okay, so in 17a, you have to find the separate equations when the lines represented by kx squared plus 8xy minus 3y squared if they are perpendicular to each other. So y given here condition. So here you can see here is a one unknown variable here, that is k. You have to find the first value of k. Okay. So to find the value of k, you have given the conditions. The line represented by the single equations are perpendicular to each other. So first you find the value of k, and after that, after finding the value of k, just replace the value of k by that, and then after you just factorize and get the equations, separate equations of lines. Okay. Now first here, given equation, given single equation, we have kx squared plus 8xy minus 3y squared is equals to 0. Okay, so now comparing with ax squared 2xy plus by squared is equals to 0, you will get the value of ak. And for the perpendicular, you just only need to know the value of a and b. Now you will get the value of b minus 3. Since the lines are perpendicular to each other, which means a plus b must be equals to 0. Now value of a is k plus b is negative 3, which is k minus 3 is equals to 0. Now you will get the value of k is equals to 3. Now replace the value of k back to the equation. Therefore the single equation becomes kx squared plus 8xy minus 3y squared is equals to 0. This is the single equations. Now replace back the value of k by 3. Okay, so 3x squared plus 8xy minus negative y squared minus 3y squared equals to 0. Now 3 3 is a 9, 3 1s 9 1s a 9, 9 minus 1, that will be 8. So 9xy minus xy minus 3y squared equals to 0. Okay, now just 3x, take 3x, what we call that, 3x common, x plus 3 3 is a 9, y. So here you just take y common. Now x plus 3y is equals to 0. Or x plus 3y, another will be 3x minus y is equals to 0. Okay, now therefore either x plus 3y is equals to 0, or 3x minus y is equals to 0. So these two are the required equation of lines. Okay, very easy, nothing to worry. Okay, so very easy. Now on further saying that if you finish this, then that's okay. If you haven't, just take a screenshot. Now I'm going into another equations. 3x1. Okay, 17. Now 18. That will be the last questions for today's video. Okay. If you have finished, then I would like to start number 18. Okay, I'm going to rub it, take a screenshot, or you can pull back the video, in a reverse directions. Okay, now I'm going to rub this. Okay, let's move on to number 18. So that the pair of straight lines 3x squared minus 2xy minus y squared is equals to 0, and another line says 3x squared minus 2xy minus y squared minus 5x plus y plus 2 is equals to 0. These are the two single lines which represent the pair of straight lines. Okay, so we have to show these lines are parallel to each other. Okay, for this case, what you have to do is just for the both cases, you just separate the line first and find their slope, equate their slope, and then after. So since the slopes are equal, you just equate the corresponding slopes. If the corresponding slopes are equal, then the lines, it will be proved that the lines are parallel to each other. So first, give an equation. So this is of 18a. Okay, so given single equation, given a single equation, we have one is 3x squared minus 2xy minus y squared is equals to 0. This is I. And another 3x squared minus 2xy minus y squared minus 5x plus y plus 2 is equals to 0. Now first try to factorize this first equation. Now from equation I. So I'm trying to write with very small writing here because it will be linear. Okay, from I we have 3x squared minus 2xy minus y squared is equals to 0. So okay, now factorize this. 3 minus 1, that will be 2. 3xy plus xy, y squared is equals to 0, or 3x will become here, x minus y, yes, plus here will be y common, x minus y is equals to 0, or x minus y, another will be 3x plus y is equals to 0. Either x minus y is equals to 0, I, or 3x plus y is equals to 0, double I. Okay, let now slope of line I is equals to, let that be m1, coefficient of x, coefficient of y is equals to minus coefficient of x, we have 1, and coefficient of y negative 1, that will be 1. So m1 will be 1. Now slope of line double I minus coefficient of x divided by coefficient of y. So for m2, coefficient of x is minus 3, x is 3, and coefficient of y is 1, so that will be minus 3. Here m2 is minus 3. So in the same way, this is from single equation I. Okay, I forgot to write here. 1, 2, this will be 3. Okay, this will be Okay, let's not consider this equation I. This I'm going to rub that, supposing. Okay. From this equation, you got two equations, I and double I, and you got the slope m1 and m2. And from another equation, 3x square minus 2xy minus y square minus 5x plus y plus 2 is equals to 0. Now try to bring down this into the quadratic functions of x, or 3x square minus 2xy minus 5x minus y square plus y plus 2 is equals to 0, or 3x square minus x 2y plus 5. So take this negative common, it will be y square minus y minus 2 is equals to 0. Now comparing with ax square plus 2x, no, not 2x, x square plus bx plus c is equals to 0. You'll get a is equals to 3, b is equals to minus 2y plus 5 inside the bracket, okay, and c we have y square minus y minus 2. So now we know x is equals to minus b plus minus b square minus 4ac divided by 2 times a, or x is equals to minus, so replace the value of minus 2y plus 5 plus minus under root b square will be minus 2y plus 5 whole square minus 4 times a we have 3, and b and c we have this whole negative s, this whole negative minus y square minus y minus 2. Okay, divide by 2 times a we have 3, or x is equals to minus minus plus 2y plus 5 plus minus under root, so minus square that will be positive 2y plus 5 whole square minus minus plus 4 3s are 12, y square minus y minus 2 divide by 2 3s are 6, or now this will be okay, oh that's not multiply, okay, now 6, this will be 6x is equals to 2y plus 5 plus minus, just expand this, 4y square plus 2 5 is 10, 20y plus 25, 12y square minus 12y minus 24, or 6x is equals to 2y plus 5 plus minus, so 4 plus 12 that will be 16y square, and plus that will be 8s 8y, 25 minus 24 that will be 1, or 6x is equals to 2y plus 5 plus minus 16y square plus 8y plus 1, this can be written